Are you ready for interview question?
I am bored of interview questions. Can we learn a new concept today?
Yeah, sure.
Okay, let's learn about signals today.
Hello everyone and welcome back to another video on this channel. So today we are going to understand what signals are and how can be used to optimize the render performance in React apps. So before we jump into what signals are, let's try to understand a common problem which is faced when we are building let's just say single page apps which are a little bit complicated using React.js. Now let's just say we have an e-commerce app where there is a sidebar component, one header component and one product grid component, where when we click on the add to cart button, the card items or the cart value here gets increased. So this gets incremented. And when we click on the sidebar, the categories get filtered as well. A pretty basic e-commerce app. Now let's jump into the code. So for this e-commerce app, we have a main component which is e-commerce app. In this, we have a cart items. So this is a shared state variable. So basically we use useState to define these cart items. Now we have passed these card items first to our header. So if we jump into the header, we see that the card item count or the total card items is passed as a prop, and this is shown here. And this card item state variable has a set card item function which is used to update the state of card items, and this is set on the handle click method of the product grid. So if you go into the product grid, for each individual product we have an on add to cart function. And in this on add to cart function, which is passed from the e-commerce app component, we are using the set card items method to update the state. Now, why was state needed in the parent component? The reason being the state variable was shared between, like the function to update the variable was used by the product card and it was being used by this cart header. So the state variable was shared, which is why we had to define it in the e-commerce app. Now we have added a console.log here for each render. So this will tell us whether which component is getting rendered at what time. So e-commerce app has a log. The product grid component itself also has a log. The header component which we just saw has a log, and the sidebar component also has a log. Now let's just get into the console. Let me just clear the console and refresh that. Now as you can see, the initially all the components are getting rendered, which is why we have this all values which are been printed out here. This is fine, like app component got rendered, then the e-commerce app component within the app component got rendered. So in the app component, we have the app component rendered as well. Then the sidebar component got rendered, then the header component, and in between that, after the header, we have the product grid rendered as well. Now let's clear the console. Now let's see what happens when we click on add to cart. Now when we click on add to cart, we see that e-commerce component got re-rendered because we clicked on add to cart function. The header component got rendered because the state variable got incremented here, and the product grid component got rendered as well, re-rendered basically. But there was a side effect, and what was that side effect? The sidebar component, which is not dependent on the state variable, got re-rendered as well. Now why did that happen? That happened because whenever state variable is shared in the parent component, and there is a change in the state variable at the parent component, or there is any change which is happening at parent component level, all the children components within the React's virtual DOM get reconciled or re-rendered again. So this is a common side effect and a common issue which is observed in React apps, which is if you have a state variable which is shared among different components, and if the parent component is using that state or is sharing that state to the children, then the side effect happens and the components which are not dependent on the state variable, they also get re-rendered. Now you will say, yeah, we can like use memoization to prevent this. So the straightforward way to prevent this is just go to the sidebar component, and instead of like entering this like this, you will write react.memo, and we will encapsulate our component within react.memo, and let's just have it here. Hit save. Now hit refresh. Now if we clear the console and if we now hit add to cart, we see that the header product grid component gets re-rendered, but the sidebar component, since it's memoized, it did not get re-rendered. Now this is one way in which you can manually handle the side effect or avoid the side effect. But in this case, the onus comes on the developers to handle the such side effects. For that, you have to detect that there is a re-render happening, there is a side effect happening, and then you have to handle it on your end instead of the framework handling it itself. And that's the problem which I am stressing on in today's video. So the reason why this problem is prominent in React app is because in case of virtual DOM, the diffing algorithm makes sure that if the parent components get re-rendered, all the children will get re-rendered as well. So this is a side effect. And let's just say if this is a complicated app and not just a simple app like this with, let's just say, 50 to 60 components, and state variable is shared between components in variety of ways or variety of directions. In that case, you have to first analyze which component is getting re-rendered unnecessary, then go to memoization and add react.memo. Now this might get improved in the future React releases. Like in the React 19 version, there is a compiler which is getting introduced. So I'm using React 19 here, and they have told that use memo and use callback is no longer needed. And I think in some future releases, even this react.memo will not be required, might possibly. But today I'm going to share another way in which we can prevent these renders from happening, and that is using signals. Now, what are signals? So signals are basically a paradigm from reactive programming in which we make sure that the only the specific parts of the DOM or the virtual DOM get updated instead of the entire DOM itself, or instead of the entire virtual DOM related to that parent component itself. So this is the problem that signals try to solve. Like if let's just say there is a state at app state and we need the state towards the children component which we just saw, then in that case the entire components get re-rendered and the re-rendering causes issues. So let's try to understand how we can solve this using signals. Now for using signals, we have to install a library which is Preact, React signals, which is Preact slash signals dash React. So we need to install this library first. Then we can create a store. This is similar to how our state management stores are. And within that, we will create a signal. So the syntax for this is we import signal from Preact signals React, and we initialize a variable using this signal similar to how we initialize state variables using new state, and we pass the initial value here, right? And then we can use this variable anywhere in the app that we want. Now the first thing that we realize is in this e-commerce app we are sharing the state using cart items, and it is being used in product grid and the header. So the first thing that we can do is instead of using the state variable, we can directly use the cart item. So we first uncomment the cart items and we import it from the store. Then we create a computed value. So what is computed value? So basically what we can do is from one signal we can derive another signal which can compute or recompute its values based on the dependent item. For example, in this case, the total cart items is computed from the cart items value, and we are just like reducing the value to get the total. We can just even pass cart items dot value, that is also fine. But just to analyze that there can be a reactive way of programming, we can use computed as well. Now instead of cart item counts, we will simply use the total cart items here, and we no longer need the state variable. So this is the first change. Now coming into the product grid component, we no longer need to like pass the state. We can directly use the cart item here and we will import it. So the cart items got imported. Then we will write a add to cart function using this signal value which we just defined. Now in this what we do is we take the cart items dot value. So basically whenever you are extracting the value from a signal, you use cart items dot value or any signal variable dot value. That is how you extract the values, and you can directly manipulate those values. For example, in this case what we do is we take the updated cart and we pass the cart items dot value there. Then we update the cart and we pass it back to the cart items dot value. Similarly, in this case, we use the cart items dot value to update the array with the new cart item. And instead of using our state variable or add to cart function that we had, we will use the add to cart function from the signals. So we no longer need the array been passed from the parent component here. So here we were like adding the cards, right? Using the item and quantity and stuff. So we are doing that, but we are doing that using the signals add to cart. And I think that's the only change that we need. We no longer need the state variables. We will remove them in some time. But let's just jump back into the browser and check what is the effect of this. So let's reload the page. Now initially all those components got rendered. Now I'll clear the console and I will click on add to cart. Now as you can see, the state variable or the values here are getting updated, but there is no re-render happening. If you see here, like add to cart is updating the cart value, but re-renders are not happening, and that's the magic of using signals in our code. That is, instead, like there is no re-render happening, but using reactive programming paradigm, this add to cart function is simply updating the signal value and no component here is getting updated. So yeah, that's the original intention of this, and this is how we can actually improve our code and make sure that the DOM elements are getting updated without any re-render happening. So this is the initial cart render, and when we click on add to cart, the cart items get updated and we don't have any logs here. Now if you want to make sure that your items are like, if you want to make sure that the components are getting the values properly, then what you can do is you can simply like lift the state up, like you can take the add to cart function in the parent component and you can pass it to product grid and header as well if you want that there is no confusion where the component is defined and where it is passed. So this cart item count that you have, you can simply pass it from e-commerce app and then you can fetch it, or you can use it directly. So another advantage of signals is you can simply take this function outside the const component. So there is no need to keep it within the component itself. You can simply write it outside as well as an external function and it will still work. So if we refresh the page and hit clear, now as you can see, okay, the product might not be present, but basically you can use these functions and you can pass the product, for example, here, and you can use it outside. So here the add to cart is present. So let me just pass the product here. And now let's refresh. Let's clear this code. And as you can see, the values get updated without any re-rendering of components. So basically, this is why signals are important in our code. They allow us to update the state or update the values which are present in the DOM without causing unnecessary re-rendering. And that is what signals basically are useful for. Now this is a comparison where the VDOM update using state variable was optimized using signals, and as you can see, the time that was needed for the scripting or the VDOM initialization, that was reduced a lot. So signals can actually help in such cases where state is lifted up to the parent components, and there is another use case which is defined here. So let's just say if you want, now sometimes you use context as well, right, to lift the state up or state outside the components. We can simply use signals to make sure that it is managed internally in a better manner. So yeah, that is why signals can be used, or that is how the signals can be used to optimize render performance in React. Now one thing to note here is using signals goes against the original paradigm of React, which is that state updates should be linear in fashion or unidirectional or should be predictable. In this case, we are like short circuiting that virtual DOM and we are directly bypassing the virtual DOM concept and updating the DOM using signals. So it goes against the React paradigm, but it's an interesting concept by which you can, or we all can, update the DOM without causing unnecessary renders. If you want to understand the basic working of how signals work internally, it is available on GitHub. So basically the data structure used here is linked list and we are using a subscribe unsubscribe model here. So there is a subscribe method somewhere down the line and yeah, this is it's present, so it subscribes. So basically all those nodes are subscribing to the events and they are unsubscribing as well. So and basically we are using linked list to manage the internal data structure of signals. So that was a simple short tutorial, or I can say a concept overview of how signals can optimize rendering performance in React. I hope you found this video useful. Subscribe to the channel for more such content in your feed. Have a nice day. Goodbye.
Why did React refuse to use signals? Because it didn't want to send mixed signals about ray renders. Follow for more such content.